Hi, this is ETC1000 group project, and here is our presentation. In Timor-Leste, child height is a key indicator of developmental progress, but stunting remains a significant issue despite recent improvements. Malnutrition and limited healthcare access contribute to high levels of stunting, which can lead to physical and cognitive impairments with long-lasting effects. Addressing these issues is crucial for Timor-Leste's future, as stunt growth hampers productivity and perpetuates poverty. This presentation examines the determinants of child height in Timor-Leste, focusing on housing, health condition, and parental education using available data.
For part B, which needs to check data for obvious errors or missing values, we use descriptive statistics in data analysis. We find three apparent errors. The first one is the maximum in mom height. Since the mom height is the height of the child's mother in centimeters, a mom with 1,500 centimeters is impossible. The second one is the count in Z height. From counting other variables or pulling the list to the bottom, you can tell that there should be 8,880 rows in total. A missing count in Z height indicates a missing value in this column. The third one is the maximum in fever. Since the fever used 1 and 0 to define whether the child has had a fever in the last week, there should be only 1 or 0 in the column, and a maximum in 2 is wrong. After comparing data such as the median, 1,500 is considered more credible when the data is typed with an extra 0. Therefore, we change it to 150. We made a descriptive summary of the revised table again. After modification of 1,500, the tallest height of the mom height was 199. Although this was somewhat unusual, it was not an obvious error, so this data were retained. For the missing value in Z height, we can use go to special cell and choose blank in find and select to find blank in C69. Considering that to ensure sufficient data, we use mean, which is negative 1.9525 to supplement the data. For the 2 in fever, considering that it is a positive screeniness, we change it to 0, which with both median and mode is equal to 0. Here's the data after we clean it. For part 1 of task C, we use summary statistics and several graphs to explore the characteristics of children's height distribution. By comparing the mean, median, and mode of Z height, you should turn to the next page. The difference between these three number key is not prominent compared with the overall data range to find the shape of the data. However, it can be easily known from the screenings that the distribution of Z height is positive. As the histogram graph shows, a large amount of data is concentrated near the middle. You can see 50% of data in the middle in light blue, while only a small amount is scattered near the tail, which is in dark blue. The information obtained from the box plot also complements the previous point, with the middle 50% of the data clustered roughly between -1 and -3. Another point is that the box plot more significantly shows that compared with the data near the end of the maximum histogram, there are only a few data points near the end of the minimum. In particular, the minimum is extremely obviously displayed outside the box. This may prove that a value like -8.7 is a very small probability event in Z height. Another point worth noting is that based on the way Z height is counted, a child is considered to be stunted if their Z height value is below -2. Therefore, we can make histogram only based on whether Z height is lower than -2. You can see on the graph at the right that more than half of children are considered to be stunted based on their Z heights.
Moving on to the next characteristics, the data provides an opportunity to look at the living condition of children in Timor-Leste. Firstly is the quality of housing, which includes electricity and toilets. Examining the aspects of electricity access, the data indicates that standard error of 0.005 suggests a sufficiently large sample size, rendering the mean statistically representative of the population. However, a relatively low mean of 0.6570 for electricity access implies that numerous households may be lack in basic electrical infrastructure. Analyzing the data further, the p-value of electricity, which falls below the 0.05, indicates that access to electricity significantly affects the dependent variable of child's growth, which is similar to the toilet variable, where its p-value also demonstrates its significance to the dependent variable. So the finding aligns with the expectation as the quality of housing has a direct bearing on living condition and health outcomes. It is crucial to address the housing deficiencies to ensure the better living condition for children to promote their overall welfare. Moving on to health and condition, the mean for the food adequacy is 0.26, indicating that on average household may not have access to sufficient quantity of food. And the diarrhea is also relatively high, where 17% of children experiencing diarrhea which can lead to the poor sanitation and lack of access to clean water. Fever is also high, where its mean is 32%. And these factors suggest that children in Timor-Leste living condition may be poor, with low access to basic necessities such as food, clean water, and sanitation. And moving on to adult and parental education. The mean for junior education, primary education, high school education for the mothers are relatively low, and the smaller proportion of mothers have completed secondary education compared to those who have completed primary education. So these variables are important as they affect the health and well-being of children, as more educated mothers may have better knowledge and resources to provide adequate care for their children, impacting the living condition of children.
In Task D, the initial step involves employing a multiple regression model to examine the connection between the various variables and the children's height. This model enables us to analyze the influence of these variables on the child's growth by assessing the coefficient and the p-values. By doing so, we can determine which variable have a significant impact on the height of a child. After studying the relationship between the variables and the children's height, we have chosen the 10 most relevant variable to the children's height. And in those 10 relevant variables, we've chosen out the 5 most significant ones. Those are mom's height, DILI, male, age, M, and food adequacy. The H0 is the null hypothesis, in which they have no relationship between the 10 variables and the Z height. Meanwhile, the alternative hypothesis is that there is a relationship between them, with the significant level being 5%. So this is the new regression model after we've taken into account the 10 variables that we've chosen. So for mom height, we can see from the figures on the left that mom's height has a very small p-value that's under 5%, meaning that we can use it to reject the null hypothesis, symboling that it has a significant effect on Z height. The correlation coefficient and regression coefficient basically means that the data follows the trend of genetic inheritance, where the child with a taller mom will also be taller. For variable 2, that is DILI, we can also see that it also has a very small p-value, which is why it's chosen to reject the null hypothesis. It also has a positive correlation between the two variables, and from that we can see that children that lives in DILI normally has better access to infrastructure and living environment, thus allowing for more growth opportunity. And in generally meaning that if the children lives in the capital, they will have more they'll be taller than the one that lives outside of it. For male, we can see that it also has a very small p-value, under 5%, meaning that it also has a significant effect on Z height. But for this, the correlation is negative, symboling that it has a slight negative correlation between with the Z height. And the regression coefficient is also negative. Those two combined telling us that if a Timor-Leste child is male, then it will be shorter than the female child. This goes against the expected value, because generally we would expect that male children will have a higher Z height than female children.
For the last variable, the food ADQ, so food ADQ has a highly significant p-value, indicating its significant in influencing Z height and rejecting the null hypothesis. There is a slight positive correlation between food ADQ and Z height, suggesting that the adequate food and nutrient contribute to higher Z height scores in children. The regression coefficient of 0.1552 implies that Z height increase by 0.1552 for each unit increase in food ADQ, reinforcing the idea that the children with access to sufficient food may grow taller compared to those without. The positive correlation and regression coefficient both support this conclusion, and Z height increased by 0.1153 for every unit increase in food ADQ. For the R and R square, by looking at the variable individually, we can see how they affect the child Z height, but it doesn't mean that the model is accurate. To prove that the model is accurate, we could need to look at the model's R square value, which in this case would be 0.1815, which is very close to the original multiple regression model with all the variables, meaning that the 5 variable in the model is linked to child growth. But as we saw with the individual analysis of the variable, some have more significant effect than others because they are directly linked with genetic or relate to nutrient which a child need to grow. The analyst reveal a positive correlation between most variable and Z height. However, the variable diarrhea exhibit that a negative correlation with the height, indicating that the child experience diarrhea, suffer nutrient loss, and require recovery, which affect their growth. Consequently, their growth may have slightly stunned. Another expectation to this pattern is observed in the relationship between a child's age and growth. Contrary to expectation, the regression model show a negative regression coefficient and correlation coefficient, indicating an inverse relationship between age and growth.
So about the policy modeling. So this is a detail of the program because of our program focus on the mom height, electricity, and toilet. So we will focus on three these variables in more detail in analysis. So why has the program been designed like that? First, correlation. Using a correlation give the output mom height, electricity, and toilet all have a positive correlation with Z height. With mom height having a stronger correlation, higher mom height and better quality of electric, and toilet lead to the higher Z height of the children. Improving the variable will have children Z height. Coefficient. Using the coefficient justify the policy inclusion of quality of housing. Multi-regression modeling provide detailed insight into the policy, specifically for testing the hypothesis prereq for the mom height, electricity, and toilet. The p-value for the mom height, electricity, and toilet are significant below 5%, indicating they positively influence Z height. Children with access to toilet quality can be expected on average 0.06902 higher than Z height, while the with electricity can be determined 0.1099 higher. Children with the bowl facility can expect 0.1790 higher. The policy includes these variables to improve Z height and reduce stun growth in children who lack access to quality house. Next is the pie chart. With the pie chart using the other data, over 50% of children in the country have stunt growth. The average mom height calculated is 151 centimeters. Then, when filtering for the stunted children and mom height below average only, then creating a pie chart, nearly 59% had mom below the average height, indicating a significant concern. The correlation about the solid mom height and has a positive correlation with Z height. Meaning higher mom height lead to higher Z height. Therefore, all three policies focus on mom height, and family with mom below the average height needs particular attention because their children are more likely to experience stunt growth. That's why the mom height is designed in the program. Next one is about the impact of the program on the children. In here, I will use in the pivot table for stunt children that have mom height below average. The column is electricity and the row is toilet. Using it with the multi-regression modeling. Firstly, it's about the policy modeling electricity program. The electric has the most positive relationship with Z height. The children have to supply electricity with higher in Z height 0.1099 units. However, based on the real data, nearly 40% of the children have stunt growth condition and they don't have a supply of electricity. However, with the supply of electricity, there is still a high percentage of stunt children, 60.88%. So due to a reasonable, we can identify that the electricity supply does not really affect too much on the Z height and also the growth condition of the children. And so using the electricity program will not have much impact on the improvement on the rate of children being stunned and therefore not really useful to be used. Toilet program. Similar for the toilet program, the toilet has a positive relationship with the Z height. The children who have access to toilet quality tend to have a higher Z height of 0.06902 unit. When considered the only two stunned children and model below the average height, 58% of the children have stunned growth condition when they lack access to toilet facility, indicating a need of the policy to prioritize improve the toilet facility. Access to toilet facility results in decrease in the rate of stunned children to 42%, indicating its positive impact on reducing stunt growth. Toilet access had a greater impact on reducing stunting, 42% compared to electricity access, 61%. Electricity program. However, the question is small, so the toilet program can be useful but not have significant impact on Z height or the rate of child stunning. Electricity and toilet program. About the electricity and toilet program, the reason for this is that individual variables have a small effect on Z height. From party, when studying the regression models separately, it is seen that individual variables have only small impact on Z height, but the combined variable can have a large impact on the outcome variable. So based on the equation, when the children have access to both toilet and electricity, the Z height will be higher, 0.1790, than the children who just have access on only the toilet or only the electricity. This highlights the importance of considering the interaction of more factors. Only 22% of stunned children have both toilet and electricity, suggest that combined programs are more impactful than individual one. And because of that reason, this is the conclusion that toilet program and electricity program, individual program, may not be impactful compared to the combined program toilet and electricity program. Then summary of the analysis of the program, we have the table. From that, our analysis indicate that electricity and the toilet program had a high average increase in Z height when compared to the other independent variable. Access to both electricity and toilet results in the lowest rate of stun children at 22%. For children whose mother have below average height. Although individual variables have a small effect on Z height, their combined impact significantly contribute to outcome variable. Therefore, we suggest ranking the program in the following order. Smaller impact is electricity program, toilet program, and then the most impact is electric and toilet program. Our recommendation solution is to implement the combined electricity and toilet program. To conclude, we found that most impactful the electricity program and toilet program based on the reasons mentioned above.